Welcome, everybody. Hey, welcome. We'll get started here in a minute. Welcome. Thanks for the join. We will get started here in a minute on some Cisco routing, IP routing using Cisco routers. Right here in the middle, these three, 1, 2, 3. Okay, let's go. Today's June 8th, dynamic routing using Open Shortest Path First, OSPF. All right, so we have some routers here, 1, 2, 3 routers, and here's our subnets, 10.10.10/24, 10.10.12, and 10.10.11. The PC over here is on 10.10.10. The PC over here is on 10.10.11. PCs, thanks for the likes, thanks for the joins, welcome. The PCs, end host doesn't run a dynamic routing protocol. Excuse me. Let me clear my throat. An end host relies on its default gateway. So here is PC 0. If I can get it in view. IP config. Yeah, this is no different than a Linux machine, a Windows machine, a smart TV in your house, a washer and dryer in your laundry room that's got Wi-Fi on it. Basic IP information, basic behaviors of internet protocol are the same when it comes to end devices. In the Internet of Things, there's a lot more. Thermostats, microwave ovens, my gosh, Apple Watches, all kinds of stuff. But an end device gets an IP address, it gets a subnet mask, and it gets a default gateway. It also gets a DNS, but we're not talking about DNS right now. We're just talking about basic IP routing. So DNS just makes our life easier. The end host, PC0, it says it right there, has a default gateway. That's the router that it sends packets to, 10.10.10.254. Well, from past lives that I've done, the Cisco King is back, baby. What's up? Thanks for the compliment. These two routers right here are acting as 10.10.10.254 from an HSRP virtual router perspective. So this is the default gateway for this PC, okay? This PC over here defaults to this router right here. Excuse me if I call those PCs routers. This PC, same thing, defaults to this router right here. Now, that gets the packets to your first hop router on either direction. But what are those routers going to do with those packets then? Well, that's the topic of our today and the last couple days. We've been talking about dynamic routing, is how these routers will exchange routes and reachability information with one another. All right. So the you can separate functions of network devices, and hey, thanks for the compliment. You can separate functions of networking equipment in control plane and forwarding plane functions. And I'll look at some of the comments in a moment. I need to complete these thoughts. And routing protocols are control information. Okay, routing protocols like OSPF, which we're going to talk about a little bit, is a control plane function. All right. What comes first, chicken or egg? I don't even know what that means, really. Some people talk about that sometimes. But it's like, what comes first? Can the router route a packet sent to it from PC using its default gateway? Can the router route that packet before or after OSPF has been enabled? Well, only after. The router has to learn routes before it can do anything with those packets. So the control information needs to be in place to then learn reachability information of said routes. These routes throughout the network. I'm pointing to them. A route is a subnet, folks. A route is an IP subnet. Okay. A route's not like this complicated like list of how to a route like on Apple Maps or Google Maps. Turn here, turn there, turn here, turn there. No, not really. That's more like a traffic engineering type of thing. But basic routing is just the next step in the process. Basic IP routing is a hop by hop deal. Okay. So this router here will learn a route for routes that it doesn't know about. And again, from what we talked about yesterday, a router only knows about routes that it's directly connected to. So this router 4 is directly connected to 10.10.11 and 10.10.12. OSPF, when initialized, these routers will tell router 4 about 10.10.10. Okay? Likewise, router 4 will tell routers 2 and 3 about 10.10.11. All right? Once that control function has taken place and that control plane protocol has shared, thanks for the likes, folks. Appreciate you. Once that control plane OSPF routing information has been shared, then each router can populate the routing table. Now, the routing table is known as the routing information base, otherwise known as RIB, the RIB. Okay? Then best routes in the RIB get put into the FIB. FIB, the forwarding information base. Okay, so the RIB shows where we learned the routes. You might recall yesterday, I'll get in here. I'll look at the CLI of router 4. Not going to be much to look at, but, shoot. By the way, if you get this, when you make a typo translating to domain server broadcast address 255.255.2, no, if you don't like that, go into your route. You got to be enabled first. Go into your router, no IP domain lookup. Now you can make all the typos you want, and the router doesn't sit there trying to do a DNS lookup on your silly typos. It's okay, so you're just basically turning off command line DNS lookup. Don't do that if you need command line. Don't, excuse me, don't do that if you rely on DNS for some things in your CLI. But if you don't use DNS in your CLI and you get tired of this crap, just turn on, just no IP domain dash lookup. All right, so looking at the routing table here, thanks for the likes. There's the codes, folks. There's the codes. The codes of show IP route tell you the source of routing information. We already talked about this yesterday. If you go out on Twitch, by the way, you can see my past TikTok lives. I'm streaming to Twitch simultaneously, and they're saved for 60 days. So there you go. If you want to see what I'm talking about right now, I'm referring to how we learned about these codes, connected and local. So when you learn an OSPF route, it's going to be the letter O. Oh, yesterday I forgot to mention, sometimes these aren't blatantly obvious, these codes. C stands for connected. L is a local route, but it also says it's directly connected. Yeah, but it's a special case directly connected route known as a local route. And it actually, does it say it up here? Yes, it does. Now, here's the one that's not obvious, the letter D. EIGRP stands for the letter D. Oh, you know what? It just occurred to me. I wonder if the letter D in EIGRP stands for dual. If you don't know what I'm talking about, Google it. DUAL. It's the diffusing update algorithm that EIGRP uses. I bet you that's what the D stands for. Oh, man. I don't even know if I ever knew that. It just hit me. Okay, so what are we talking about? Yeah, so the routing table is the RIB, the routing information base, and the RIB tells you where the route was learned from, connected or EIGRP, or let me take a sip of coffee. or OSPF. And then there's a forwarding table. Control plane and forwarding plane separation, excuse me, is a lot more evident in some of the higher grade routers where you have dedicated routing processor hardware and dedicated line card hardware. Also, where you have operating systems like iOS XR that or Junos that is built for control and forwarding plane separation. And so anyway, you can now. This is the routing information base. The forwarding information base in a Cisco router is known as the Cisco Express Forwarding Table. Show IPsef. There we go. Some routers will actually show Ceph, but this one you need show IPsef. There's two different ways to do it, and I think in some routers. Cisco Express Forwarding. This is the actual forwarding table. Okay? So anyway, I'm not going to get too deep into that, but I just wanted to say that once these routers have learned routes, the best routes get put into the forwarding table from the rib to the fib. I ain't fibbing. This is not a fib. This is truth. This is the fib. So that's that. Oh, okay. So from yesterday, I talked about dynamically learned path D. Not really. I mean, okay, could be Sagonizer, but I mean, there's so many other. There's so many. These are all. I mean, there's so many other dynamically learned options in here. ISIS, EIGRP, EX for external EIGRP, O for OSPF. And so to categorize this one as dynamically learned for EIGRP would omit all these other ones that are also dynamically learned. So, I mean, I don't think that the D stands for that. You could be onto something. I can't say for sure. So yeah, I mean that's a good guess. If you're guessing, if you know for sure, send us a link. Drop a link where we can look that up or verify that. Can you add a route reflector at some point and speak to it? Absolutely. Yeah, and you know what? Real quick, since you bring it up, I'm going to show you a route reflector video that I did that would probably come in very handy. And let me see if I can pull it up here real quick. If you look at the link in my bio, it shows my YouTube channel, and I call it Aaron B and BTT, bit nibble bite, feeding you network knowledge one bit nibble bite at a time. So if you go into videos and Control F, reflector, reflect. Oh, you have to scroll down. I think you have to scroll down to look at all the different titles and stuff. Where did I talk about? Oh, here we go. Juniper and Cisco IBGP scaling using dual route reflectors. Yeah, that's it right there. So let me see if I can blow that up. I covered a lot of good information about route reflectors in this video right here. Where is it? There it is. This one right here. Cisco and Juniper service provider scaling multi-protocol internal BGP with redundant route reflectors. If you're going to use route reflectors, you're going to want to make them redundantly. One single route reflector is great in its ability to relax the full mesh rule of BGP, but you've now created a single point of failure. So if you're going to do route reflectors, make sure you do them redundantly. And I talk about it in Cisco iOS. I think it's iOS XR that I talked about here. It's been a while since I've looked at this. And Juniper Junos. All right. So yeah. So that's how the routers will learn routing information, and then they will take the best routes and put them into the forwarding table, into the forwarding information base. And yesterday we talked about, there's only a few routing protocols to pick from. It's not like a super hard decision, but it's a decision that you don't want to take lightly. And I wanted to emphasize this because it's not something you do very often. The routing protocol that you're running is foundational to the functioning of your network. The larger your network gets, as you put routers all over the place out here and have different subnets all over the place, you're going to be relying on this routing protocol to grow your network. So you're not going to want to change your routing protocol very often. It's not going to be very easy to change your routing protocol. All right, so think about it, give it some thought, talk it over with your team, do some research on it if you're a one-man show or a one-woman show in your IT group and it's all on you to decide what you're going to do. Give it some thought, do some research, and just a quick recap, the typical interior gateway routing protocol that you would choose will, by process of elimination, it'll eliminate BGP. You're probably not going to build your internal network, IGP underlay network, I'll emphasize, on BGP. Now, I said yesterday, a lot of the things that are going on these days are actually suggesting eBGP underlay. But I'm just going to talk about it from a traditional sense and the way that I run the network that I'm in control of. BGP is not my underlay IGP. Okay, that leaves a few more here. If you don't want to be locked into Cisco proprietary, then you're not going to use EIGRP. Okay, if you want something industry standard, multi-vendor interoperability, there's an option there, OSPF. Here's another option, RIP. But RIP is so old. Some people call it rest in peace. Just let it die. Rest in peace, RIP. And you're not going to use RIP if you want something fast. And I'm going to emphasize one more time from yesterday, newer types of things going on in networks with traffic engineering, segment routing, and things like that require the link state capabilities of OSPF. Another one not listed here is ISIS. So I would say OSPF for simplicity, ISIS maybe for more protocol agnostic functions. And I say that meaning I'm pretty sure ISIS does not, I know ISIS does not have a different version for IPv6. ISIS is IPv4, IPv6 friendly and agnostic to either one, or it can handle both of them. Okay, OSPF, on the other hand, has a different version. OSPF version 2 is for IPv4. OSPF version 3 is for IPv6. So you're going to have to turn up a second version of OSPF in your core if you're running IPv6 in your core when you start doing IPv6. And so anyway, yeah, so that's why I'm going with IPv6 in this video. All right, so let's get going. We're over here on PC 0. We're going to try to ping PC 1. Let me do it persistently. You got to put the -T in front when you're using this packet tracer. Okay, so 10.10.10.3 is telling us destination host unreachable. Why did it pause? Okay, 10.10.10.3 is telling us destination host unreachable. Let me move some of this stuff over so we can see it, because I like to look at it in real time. I'll just cover that up. Okay. And 10.10.10.3 is one of these routers right here. Okay, so let's just make sure these routers are still running HSRP successfully. I fixed our channel group problem, by the way. We don't have to deal with that anymore. We did some link aggregation topics in previous TikTok lives where I was doing link aggregation here, and I got rid of it because these routers would not keep the link aggregation config. Show standby brief. Okay, good. We are active. This router, router 3, is active locally, and its IP address is 10.10.10.3, which is why that's the one we're getting the replies from right here on the PC, because we are defaulting to our HSRP active router. And it's replying back that it doesn't have a route to 10.10.11. Show IP routes. No route to 10.10.11. We have a connected route for 10.10.10. We have a connected route for 10.10.12. All right. And you know what? I'm going to pause. Not right now, but maybe tomorrow or the next day at some point. And I'm going to go deeper into IP subnetting, because as soon as you start building out a network, you better be solid in IP subnetting, or you're going to create problems. And I think I'm going to take some time to just give some tips and tricks on IP subnetting and documenting. You got to document your IP subnets, and you got to share your document with anybody that is also managing the network with you. Everybody has to be on the same page, no pun intended, using that same page, that same spreadsheet or whatever the heck it is, tool for documenting your subnetting. Okay, so let's get into these routers, and you can quickly turn up OSPF with a couple commands. I'm going to put it in a notepad. I'm not even going to do a loopback yet. Maybe we'll come back and do that tomorrow, but I'd really like to just... Actually, no, I'm going to do a loopback, which again emphasizes why you need a IP document to track all of your IP addresses, because I'm about to need new IP addresses right now. So how about this? Let's go with, since we're on the 10.10 scheme, let's stay with that, and let's go up to the top. So 10.10.255.0/24 will be router loopbacks. Okay, so let's make the first one. And we will use the last octet will be the router number. So we have router 2, 3, and 4. Forgive me, there's not a router 1. It was probably another router I used earlier and I stopped using it. So this is going to be router 2, 10.10.255.2, router 3, router 4, okay, and let's put that address in there. This is going to be for router 2. So create your loopback, because this is going to be what is used for the router ID when OSPF initializes. Okay? And then we go into the router process. This number is a it's locally significant process ID. Okay? It's not something that has to be the same on every router, but why complicate your network if you don't have to? Use the same router ID. Okay, so we'll use the same router ID on, process ID. We will use the same process ID on these three routers. Router OSPF 1, and I think it's network. Now, you can quickly bring up OSPF on all your interfaces if you use a all zero filter. This is a filter, this command. Let me make sure I've got this right so far. I'm going to go ahead and paste this in to router 2. Let's paste that in. Okay, the loopback came up. The network command, network number. This is actually a filter that says any IP address on this router that matches this filter starts sending out OSPF multicast hellos every few seconds. I forget what it's, every 5 or 10 seconds. And so that's what this is. It's a filter. The next is a wildcard mask, which is the reverse mask. Okay, that's what a wildcard mask is. Everything you've learned about subnet masking, where 255 is the significant bits that define the network portion, okay? That the opposite is true about a wildcard mask. It would be zeros that define the network mask. So if we say all zeros, that means we don't, let me think about that. All of them are significant? I can't remember. Oh, shoot. Let me see. It's called packet tracer. It's made by Cisco. Somebody tell me if the wildcard mask of all zeros or all ones. Wait, all ones would mean they don't have to match. I'm forgetting. All ones would mean they don't have to match. We don't care. Let's try that. Then you have to put it in an area, and we're going to call it area 0. Okay? So let's try that. Do show IP OSPF interface brief, or IP interface. All right, look at that. So it says our OSPF interfaces are G00, G01, and loopback 0. And they're all running OSPF with this statement. You know what I'm going to do? I'm going to change that mask to all zeros, which means they have to match. And I wonder if you get the same, I can't remember. Include proto, do show, oh, I can't. Show IP OSPF interface, include proto. I can't use the pipe include with the show IP OSPF interface command. I'm going to have to move to GNS3 or even G one of these days because I'm getting tired of some of the limitations in packet tracer. So let's go back into the OSPF process. Let's say no to this. Let's look at that again. What? Oh, wait. Did that just remove? No network. Let's say no network 255. Or no network 00. What? Do show run. Let's look for OSPF. Do show IP OSPF interface. We're still running OSPF. No, let's just get rid of it. That's weird. I got rid of the network statement. It's still showing OSPF interfaces. How weird. I just got rid of the... thought I did. Let's do it again. No router OSPF. There we go. Oh, you have to exit out of the router process. Okay, so let's do that again, because I'm curious if that mask filter will work with all zeros. Let's try this real quick. No, it won't. Look at that. Okay, so you have to put 255s for don't care bits. So if you're saying all zeros for a filter on the IP addresses of interfaces and you want to run it on all of them, you have to say I don't care with the all ones mask, which is the opposite. You know, that's the wildcard mask. So as you can see, do show IP interface, do show IP OSPF interface shows nothing. Let's change this to a mask of all ones. First, let's get rid of that. Let's go back in because this thing's acting weird. And let's put that all ones mask back on there. Where was it? It's in here somewhere. Okay, not enough room in the buffer, I guess. The command wasn't there anymore. Now, do show IP OSPF interface. There we go. All right, so that's how to initialize OSPF. It was really simple. This is just basic. How to quickly turn up OSPF. There you go. There's the process. Router OSPF 1, network of all zeros, wildcard mask of all ones, and then you tell it what area. And then show IP OSPF interface shows that we are running OSPF on every interface. Okay? We're going to talk about passive interfaces tomorrow. and how to not send out hellos on segments, network segments that you don't intend to establish neighbors with. It's efficiency, it's security. Okay, show IP OSPF overview. Oh, interesting. Or show OSPF. That's usually the IPv6 version. Show IP OSPF. Just hit enter. Oh, okay. I think overview might be Junos. I can't remember. So show IP OSPF says here's the routing process, OSPF 1, with an ID of 10.10.255.2. That was our loopback. Okay. And some information about OSPF in here. There's my timer. We're about out of time. There's the backbone area. Interestingly, check it out. That's kind of cool. We defined it as area 0, but it tells you this is, by definition, the backbone area. All right? We'll talk about the backbone area a little bit more as time goes on while we work with OSPF. Show IP OSPF neighbors. None. It's because we need to turn up OSPF on the other routers. We'll get to that later. Show OSPF, show IP OSPF topology or database, I think it is. This is where a lot of the magic takes place with OSPF. It's the underlying link state database, the LSDB, otherwise known as the topology database. This is where all the LSAs, the link state advertisements or packets, however you want to call them, exist and live, is in the topology database. Okay? Show IP OSPF tells you what your local database is. Right now, we only have one router link state. We'll talk about the different types of LSAs, link state advertisements, or we just lost Wi-Fi. Sorry about that. I don't know what happened, but my Wi-Fi glitched there for a moment. We're back now. Okay, and so we have just initialized OSPF on router 2, not on router 3 or 4 yet, and so we'll have to get to that tomorrow. I'm going to look at the comments here, anything I might have been missing. Video on loading GNS3. That'd be cool. I got a lot of EVNG videos on how to load router operating systems under the hood in EVNG and the Linux host that's hosting EVNG out on my YouTube channel. Link is in the bio if you want to look at that. I haven't done GNS3 in a while, so just a second. I'm trying to look at some of these other comments, and my phone is getting weird on me. Okay. Yeah, here, let me look at some of these closing comments. Twitch address? Yeah, it's right here. Where is that notepad? It's just Twitch TV, Aaron Tech Talk. There you go. You're welcome. Yeah, I do like teaching. I actually teach Cisco and Juniper, and I'm mentoring my son through CCNA. A lot of the videos are in my my TikTok profile. You can see some of the stuff I'm going through. I mean, I have fun doing this. I like networking, and I like talking about it and teaching about it. It's kind of fun, and it helps me. It helps me refresh my knowledge of what I once knew and have forgotten, and I get to learn it all over again as I talk through it. So thank y'all for your patience. Ever work on Patriot System? No, I don't even know what that is. Yeah, YouTube channel, Life 3 Coach, if I said that right, I should probably put it here. It's right here. We were looking at that a moment ago. And it's Aaron Gould Network Knowledge. YouTube, Aaron Gould Network Knowledge. And I'll just put it here. And my browser's acting up, if you can bear with me for a second. Why? Oh, here it is. It's over here. There we go. I'll have to just, there you go, youtube.com, Aaron Gould Network Knowledge. And here's all the videos. I need to add some more I'm going to be putting some on EVP and VXLAN out here. I've been really digging deep into that lately. And I'll probably put that right there for future reference. My email address is in my description of my YouTube channel. If you want to chat about anything via email, that's fine. I'll try to help when and how I am able as time permits and things, you know. So, Nmap and Netcat. Yeah, some people use those. I used it for research. I used Netcat for research back in the day when I was working on some security stuff. But anyway, it was fun, folks. I look forward to the next time. Y'all have a nice rest of the day.